All right, pre-algebra students, welcome to your very first lesson. Now, at this point, I'm hoping you've already done your facts practice for lesson 1. And you have your notes here that I have created. So you either have a copy of them at home that you already that I already gave your parent, or you had to print this off the computer. Either way, I want you to have this in front of you while we go through the notes, okay? So this is how we learn the lesson. And lesson 1 is, in fact, the first few lessons are going to be a lot of review, and you might already know this, but you might have done this in a different type of textbook, and Saxon might do it different, and so I just want to make sure we do actually do the review. So we'll go through it quick. So that means this one was 4 pages, but it's not 4 pages of anything that's too complicated. All right, so I already see here I should have had an S. It's counting numbers, okay? Counting numbers, we're talking about, we kind of, the number system has lots of different numbers. And when you start out by counting when you're little, like my son CJ, when he started counting, he started with the number 1. And so we call those natural numbers. He used to count 1, 2, 3, 4, and so on. Okay, so whatever I write on the paper, I want you to go ahead and write as well. So those are the counting numbers, or we call them natural numbers. Those are synonymous. That means the same thing, counting numbers or natural numbers. So if we say the natural number line, it's the numbers 1, 2, 3, 4, all the way up to infinity, on and on. But if you notice, nothing before the number 1. Then kids get older and they find out that there's a number 0 involved. And so the set of numbers that has 0 included, plus all the counting numbers, would be called the whole numbers. So there's only one number that was missing in the natural number system, and that's 0. It's the only difference. Okay? Now, as you know, in math, there are 4 fundamental operations. Now, an operation in math is like a calculation. When you get to calculate something, it's an operation. And the 4 fundamental operations in arithmetic, notice I didn't say algebra or pre-algebra or calculus. We're talking about just arithmetic, and that is adding, subtracting, or subtraction, whatever you want to write. Adding, subtracting. I'm going to just write mult. I'm going to abbreviate that, and you may too. And divide. Okay, so those are the 4 things we can do. Add, subtract, multiply, or divide. Okay, so now let's talk about some vocabulary for addition. When in addition, we have 2 vocabulary words. We have addends, and we have the sum. Now the addends are the numbers that are being added. And the sum is an answer to it. Yes, I know you've heard this before, but I am reviewing. It has been a whole summer, and you might be a little rusty. So the sum is an answer to an addition problem. Now, the reason these notes are so long is we're going to go through this with adding, subtracting, multiplying, dividing. They all have their own vocabulary. All right, so we have some examples. Example 1 here is 36 plus 472 plus 3,614. Why are they giving this to you as an example? Again, it's to warm you up for the year and to make sure we know how to line things up properly. So when I'm adding, we can start with the first number, and I always add vertically. Okay, 36, unless I try and do it in my head. We're not going to do that with something this large. 36 plus 472. Notice I have my ones lined up. Plus 3, 6, 1, 4. So we really wanted to make sure your 6, 2, and 4 were lined up. So again, if I'm doing it, I also want you to do it. You can even pause me and see if you get the right answer, and then go ahead and watch again. Or just turn me down and I will work it out. Or we could do it all together. Okay, 6 plus 2 is 8, plus 4 is 12. Carry the 1. I always kind of do the smaller ones first, so I would put the 1, and the 3. So that's 5 plus 7 is another 12. Carry the 1. 10, 11, carry the 1, and you should get 4,122. And I like to box my answers. And I like it when my students box their answers because my eye will be drawn right to where the answer is when I'm going to grade, especially your tests and quizzes. All right, so here is another one. Now we have some decimals, so that's why they put it in. Just a little review on adding decimals. Okay, so we have $1.45 and we have $6. So that goes right here, and we can put in the zeros where the change would be. And 8 cents. Now, it was tempting to put $8, but it's 8 cents. Okay, go ahead and put. So I had to change the 8 into a decimal. And then we go ahead and add those. And so some of you might be a little bit bummed because you're expecting pre-algebra to be way more exciting than arithmetic that you have done over and over, but we do have to review this and make sure you really have this down. And like I said, it's been a whole summer. You might be a little rusty. All right, so move on to page 2. We're going to go through the same things, but this time subtraction. All right, subtraction has a subtrahend, and honestly, I never use that term, but I do need to remember it. A minuend and a difference. Okay, so think about subtraction. You have one number minus another number equals the answer. We need to know which one is which. Okay, the subtrahend is the number you are subtracting with. Okay, so you are subtracting the subtrahend. So we are subtracting with the subtrahend, and we are subtracting from, and I'll put this down here so it makes more sense, the minuend. The difference is the answer. That's the easiest part. The answer to a, I'm just going to write, yeah, subtraction. Hopefully you can fit that in. Okay, so what this means though is, maybe if you remember it this way, the minuend minus the subtrahend equals the difference. Now this might pop up on a test or quiz, so if you remember it this way, min minus sub equals diff, okay? Min minus sub equals diff. Minuend minus subtrahend equals difference. All right, now let's move on and do some examples. Again, this might be super easy for you, or you might be still thinking about your summer vacation and how much fun you had and are a little distracted. So let's focus. Let's go ahead and subtract this. All right, it has been a while. You might already be like, oh, we have a problem. 7 minus 8 can't happen. 7's not big enough. So the 7 looks next door and goes, oh, can I borrow from you? Oh, wait, you're a 0. I can't borrow anything from the 0. You've got nothing. So then we got to go even farther next door, and the 2 has to give something up and becomes a 1. And then makes this into a 10, gives 1 here, but oh, the 10 has to loan out to the 7, so that 10 now becomes a 9, and now the 7 is a 17. So now we have 17 minus 8 is 9. 9 minus 4 is 5. Oh, 1 cannot subtract 9, so we got to borrow from the 5 and give the 1 there. So now we've got 11 minus 9 is 2. 4 comes down, or 4 minus 0, and there is our final answer. Now I went through that fast, and you might all of a sudden realize it's really math, and it's really happening, and school is really starting, and this overwhelmed you. Go ahead and back up and try again. Okay, when you have to borrow from a 0, sometimes it gets a little confusing when you are out of math shape. Okay, so this one is $5 minus 25 cents. So that actually looks like this: 5.00 minus 0.25. Now I want you to notice I put a dollar sign here, but I didn't here. In addition and subtraction, when we're dealing with dollar signs, It's really most important maybe if you put it just once and then it's assumed the other one's down there. I'm not a stickler. I do need to see it at least somewhere in your adding and subtracting problem, usually on the top number, or I could have put it here, but I'm just showing you that I left it out, and that is okay. So with subtraction, again, we need to line up those decimals and bring it down. And we can't do 0 minus 5. We can't borrow from this 0, so we've got to go all the way to the 5. And he gives stuff up, becomes a 4. Gives a 1 to this guy, but oh, he's got to give 1 up. Gives a 1 to this guy. So now we've got 10 minus 5, 9 minus 2, and 4 minus 0. And we do need to make sure that $sign is in the answer to make sure it is correct. And there it is, $4.75. This one you might have been able to do in your head. Obviously, if you took a quarter away from your $5, you'd have $4.75. But in this case, I did want us to practice the long subtraction, but you can always use mental math to check your work. Okay? So most of the time, I do need to see work done, in case you're wondering. All right, now we're going to take multiplication. So we've done adding and subtracting, and now we're going to talk about multiplication. Multiplication has factors. Factors are the numbers that are being multiplied. Okay, the product is the answer to a multiplication problem. Okay. Now, I don't know if you did Saxon 7-6 before you moved on to this. If you're not familiar with this yet, I do want you to notice that there are lots of ways to show multiplication. Okay, and I believe now that we're in pre-algebra, the book is going to use a times sign a couple times, the X, but I would like to steer away from that when it's up to us. So instead of an X, they put a dot. That means times. And I was taught when I was younger that it's kind of like taking your X, your multiplication sign, and getting rid of and just leaving its intersection. That's the dot, and that's why so it's kind of like multiplication, but the X actually disappeared and just left its dot in the middle. Okay, so this means times. This could also be written this way, 164 times 23. We could have it in a parenthesis. Anytime things are right next to each other with a parenthesis, that also means times. This could have been written, both of them in a parenthesis. That also means times. And if they are letters, let's say we were doing 23 times an unknown number, we could even put it right there, and that means times. That means 23 times something, whatever B stands for. So you're going to see multiplication in a lot of different forms, okay? And we'll talk about that when they pop up. But right now we just had the dot, so we're going to do 164 times 23. So I'm writing it up here so I have enough room because we have double-digit multiplication. All right, so we start with our 3 and multiply him by everybody. 3 times 4 is 12, carry the 1. 3 times 6 is 18, plus 1 is 19, so we carry the 1. 3 times 1 is 3, plus 1 is 4. And now what I always do is when I move over to this digit, now we're kind of down here, so you've got to put a placeholder there, a 0. So when we move to this place, we put a 0 here. Just a little reminder. So 2 times 4 is 8. 2 times 6, oh, and I sometimes like to scribble these out so I don't use the wrong number that I carried. So 2 times 4 is 8. 2 times 6 is 12. Carry the 1. 2 times 1 is 2. Plus 1 is 3. And now we add 2, 17, carry the 1, 7, and 3. And there's our final answer. So make sure that's what you got on that. And if you get stuck, go ahead and redo it and make sure you can figure out how to get 3,772. All right, so we're moving right along. We have a couple more practice problems. or sorry, we call these examples. We have a couple more examples. Okay, now we're going to do, so we're doing money, which is multiplying decimals, and in the last book we did talk about the rules, so I'm going to go ahead and go through those again with you. So we're doing $4.68 times 20. All right, so here's the nice thing about this, is we're multiplying by a nice multiple of 10, so meaning we have a 0 right there. So that means we can already put our placeholder right there, okay? Instead of having to do a bunch of zeros and then come down to the next level. So we don't need to multiply 0 times everybody, because we already know there's 0. So we put a placeholder and move on and start dealing with this 2. Okay, 2 times 8 is 16, carry the 1. 2 times 6 is 12, carry the 1, there's 13, carry the 1. 8, 9, okay? So we have 9360. Now the rules of multiplying by decimals, I hope you remember this, is we count from here the number of decimals we have in the problem. So I see here we have 2 digits behind a decimal number. So that means we have 2 digits behind the decimal number here. Okay? So if we have 2 digits, if this had been 0.20, we would have had 4 digits. It would have been 0.93. So that, I am guessing, you have not done all summer. Okay, there's your review. Don't worry, you get to do lots of this in your homework too. Get to practice it. All right, 5 times 29 cents. We're actually going to rewrite 29 cents as a decimal times 5. Now, notice how I put the 29 on top. Anything that has more digits, I always put on top, even if it's a decimal and this is a whole number. I like to put the one with more digits on top. All right, so we're going to do 5 times 9 is 45. Carry the 4. 5, 10, 14. Okay, so now we have 145. And then I go back up here. I go 2 digits behind the decimal. So we go from from right to left. 1, 2, put the decimal. And there's your answer, $1.45. And it's always good to use common sense. If I had 29 cents, if I had 5 groups of 29 cents, would it be reasonable to have $1.45? I think so. So that would be a good appropriate answer. Now we're going to go on to dividing. And dividing has 3 more vocabulary words. Okay. The dividend is the number being divided. Okay. It's what we're starting out with. So the dividend is what is being divided. The divisor is the number you are dividing by. And the quotient is obviously the answer to a division problem. All right, so let's put this into a visual that you might like better. We can show division lots of different ways. We can show it as a fraction. So you would have dividend over divisor equals quotient. So go ahead and write that. Or you might have dividend divided by divisor equals quotient. And the other way would be dividend divided by divisor equals quotient. So I have three forms of the same thing with the vocabulary. So dividend divided by divisor equals quotient. All right. Now we're going to divide 1, 2, 3, 4 divided by 5, 6. All right. So you might already be a little bummed about that because it's double-digit division. No one really gets excited when they see that. Myself included. I'll be honest on that one. I never got excited dividing by double or triple or quadruple digits. So here's how we set it up. All right, 56 into, I'm going to cover that up. And I'm going to go, okay, well 60 goes into 120, so I'm rounding, right? And it does that twice. So and then I'm going to do 2 times 56. The way I do it is I go 2 times 6 is 12 carry the 1. 2 times 5 is 10, carry the 1. And there we get 112. Or you could have just done it off to the side. You could have gone, okay, what's 56 times 2? Down to 1, and gotten it. Sorry, I did it wrong. 112. So that is also allowed. And we subtract. 3 minus 2 is 1. 2 minus 1 is 1. 14. All right, well, luckily we already did 2 times 56, and that was 112. So it looks like we're going to have a 2 again. 2 times 6 is 12. 2, carry the 1. 2 times 5 is 10. Add the 1. All right, now we have a remainder. And the way the book put it was R2. I don't want to write remainder 2. You guys are beyond that, bigger than that. And what we want to do is always answer, if we have a remainder, as a fraction or a decimal. So let's do your remainder as a fraction. So we have 22 and 2/56. Unfortunately, 2/56 can be reduced because 2 goes into 56. So what that reduces to is 22, and so we can divide the top and bottom by 2. This is what I'm doing, in case you weren't sure. All right, 56 divided by 2. Well, maybe we could do this in our head. 50 divided by 2 is 25. Okay, so 52 divided by 2 would be 26. 54 divided by would be 27, and so 56 divided by 2 is 28. Or you could have done that out. I was trying to save us some time. So just know how I got that fraction, and go ahead and write it down. Okay? The other is taking a division, dividing a decimal by a number, so $12.60 divided by 5. With decimals, I could put a $sign there. You always, if you're dividing, if your dividend is a decimal, but this is not, then all you do is move this decimal up there, so he's ready for the answer. All right, 12 divided by 5 is 2. Subtract, bring down the 6. 26 divided by 5 is 5. Subtract, bring down that, 2. And there we go, $2.52. Okay, so make sure that's what you have. All right, we're almost done with this lesson. We just have another concept I do believe we talked about in 7.6, but let's just review it. Variables are letters or symbols, letters that represent an unknown number. So it means we don't know. So rather than putting a question mark, we use letters, okay? So variables are, just write, they are letters of the alphabet. A, B, C, you're going to see a lot of A, X, Y, lots of options, okay? M, N. And evaluate means calculate the answer, basically, if they give you values for the letter. So let's just do an example so you know what I'm talking about. All right, this says evaluate each expression for x equals 10 and y equals 5. Okay, so that means where we see, and I really am a stickler about this, when you evaluate, I want you to put parentheses where there was a letter, meaning we write this x plus y, and we write it like this. Okay, and we would do it on letter B too. And you'll see why. It will make it so much easier when these get more complicated this year. Okay, you see I have all those parentheses. I just took out the letter and put an empty parenthesis. Okay, and it says when x is 10. All right, so we put a 10 in this parenthesis and a 5 in this one. Okay, and then we calculate. 10 plus 5 is 15. So there's the answer to our letter A. Okay, then we replace it with a 10 and a 5. 10 minus 5 is 5. That's your answer for letter B. This one is, put a 10 in there and a 5 in here. This means 10 times 5. which is 50. And then this one is 10 over 5, which means 10 divided by 5, which equals 2. Okay? Now, your paper should be headed. Have its heading, just like this. Okay? Lesson 1. And like I said, I think in the example where I showed you, or the very first video that was kind of introduction, I already went through some of the practice set, and then you're going to do the mixed practice, okay? And that would be the odds, unless you are going to be doing all of them. And then we go and check, okay? So you're going to maybe do all of your practice, check the answer key, make sure you had no mistakes here. If you had a mistake, go ahead and redo it on a fresh piece of paper or where you have room at the end of your lesson, okay? So maybe just have another piece of paper that has your corrections, and you'll staple it to this. So you'll fix your practice problems or mark it and then fix it, and then you'll work through your problem set, and again, take the answer key, check, mark if you got any of them wrong, try them again on a new sheet of paper, staple them together, and that's what you will turn into me. Call if any of this doesn't make sense. You'll get used to it as we go along, but it's a lot of information on how to do all of this as far as turning in, heading your paper and all that at the beginning of the year. So we will work it out. If you get stuck, call me, email me, or text me. All right, enjoy.